This is testosterone, a steroid hormone. Carbon, hydrogen, and oxygen atoms are labeled to show its molecular structure. Testosterone has a 4-ring steroid backbone. Its functional groups determine hormonal activity. Testosterone is produced and regulated by the hypothalamic pituitary gonadal axis, the HPG axis. The hypothalamus releases GnRH, stimulating the pituitary to secrete LH and FSH, and LH prompts Leydig cells in the testes to synthesize testosterone. Circulating testosterone exerts negative feedback on the hypothalamus and pituitary to regulate production. Testosterone is synthesized from cholesterol and Leydig cells through sequential enzymatic steps of steroidogenesis. In blood, most testosterone is bound to SHBG or albumin. A small free fraction is biologically active. Within target tissues, testosterone can be reduced to dihydrotestosterone or aromatized to estradiol, actions that modify its effects. Testosterone or DHT binds the androgen receptor, and the receptor complex moves into the nucleus to regulate gene transcription. This triggers transcription of specific genes, increasing protein synthesis, and promoting cellular growth and differentiation. In skeletal muscle, testosterone enhances protein synthesis, increasing fiber size and strength over time. Testosterone supports bone health by stimulating bone formation and maintaining mineral density. It also increases erythropoiesis, raising red blood cell mass partly via stimulation of erythropoietin and marrow activity. During puberty, testosterone drives voice deepening, facial and body hair growth, and development of secondary sexual characteristics. In adults, it influences libido, mood and vitality, and ongoing bone maintenance. Fertility depends on intratesticular testosterone regulated by LH. Functions: muscle growth, bone density, red blood cell production, and mood and libido. Medically, testosterone replacement therapy is indicated for men with documented hypogonadism and symptoms. Available forms include topical gels, patches, injections, and subcutaneous pellets. Choice depends on clinical context. Benefits of appropriate therapy can include improved energy, sexual function, increased lean mass, and bone density. Clinical benefits should be weighed against potential risks and monitored regularly. Risks include erythrocytosis, suppression of spermatogenesis leading to reduced fertility, potential cardiovascular and thrombotic considerations, and side effects such as acne, gynecomastia, and exacerbation of sleep apnea in susceptible individuals. Exogenous testosterone suppresses GnRH and pituitary LH-FSH, lowering intratesticular testosterone and impairing sperm production. An important counseling point: patients on therapy require monitoring of serum testosterone, hematocrit, PSA, and other relevant labs. Contraindications include known prostate or breast cancer. Pregnancy is an absolute contraindication. For patients wishing to preserve fertility, alternatives include HCG therapy or agents like clomiphene that stimulate endogenous gonadotropins. Individualized discussion and endocrine referral are commonly indicated. Clinical guidelines support therapy for symptomatic documented hypogonadism. Cardiovascular safety signals are mixed and require case-by-case assessment. Key takeaway: testosterone is central to growth, metabolism, and reproduction. Mechanism: actions are mediated largely via androgen receptor-driven gene transcription. Therapy is appropriate for confirmed hypogonadism. Risks necessitate monitoring. Discuss fertility implications before starting treatment. As a molecular signal, testosterone coordinates many physiological systems. Testosterone, a key hormone in human physiology. For clinical management, consult current endocrinology and urology guidelines. This presentation is for educational purposes.